Eager beaver.
You give me the cue, Art. You give me the cue.
You go ahead.
Hi, everybody. My name is Raymond. This is FMT122, Introduction to PLCs. I basically was fiddling with multiple ideas. I wanted to simulate the light being a switch paired with one fan that would represent like a fan coil, a heating coil, and then similarly with the second light and the other fan, that would be cooling coil, and then the third light here would be another switch to, like an actuator for a damper in the, if you recall for, let's say, your economizer, you want to turn that 100% on. But so instead of, doing what Kurt did over there with a real, 3/4 inch plywood and run a bunch of relays, Art presented another option, which is using these breadboards. And I had a huge learning curve because I've never dealt with breadboards, but a little background to it is you have this breadboard here, they're wired internally. These green cables here that connect to the PLC, this is acting as your common, so all the greens are jumpered together into that common terminal right here, this little output, and all the positive leads for the light bulb paired with this fan, similarly with light 2 here and let's say fan 2, all these are plugged into an individual output on the PLC. And then with just the PLC, I just have a simple timer program to have each output being triggered by a timer at the, once it completes the preset of 5 seconds, it'll cancel and it'll start the timer for the next one. I guess one thing I learned from this project is that, with these small LED bulbs, because it has such a low amp draw, 24 volts across, this bulb would fry it. And so, you have to put in these large resistors. And what I have right here in this board setup is a 9K resistor here. For these fans, the same thing. If you don't put resistors, you can fry the board and fry the fan itself. So after some minor, Ohm's law, V equals IR, we were able to kind of run it and then play around with the resistance. Right now we have 200 ohms right here. They're 1 watt each. So this setup was free, so don't feel pressured or the need to spend a lot of money. I was able to just pull parts, pick and pull here at San Jose City College, and yeah, it was a huge learning curve. But it was really interesting to learn that with just a couple of male jumper cables, I was able to put this small assembly and simulate what a typical plant operation is. So that's my project. You guys have any questions?
Are you gonna run it?
It's already running. It's on reset.
Okay. Any questions?
No, that's
What
cool.
resistor do you have to use for the smaller fan?
For the smaller fan, so initially we have 300. So you have this resistance running through this terminal, and then the leads have to connect. So if you kind of come up closer here, where it runs on this row, we have one vertical that's going down right here.
Yeah.
And then with 300 ohms, the fan tends to kind of not spin as fast, right? Because there's too much resistance.
Right.
And then if you plug it on the left end, it's actually only providing 200 ohms, so it's able to spin a lot faster. Whereas in this, on the second fan here, if you notice this positive lead coming out from the output, it's actually plugged on this side, so it's actually taking 300 ohms.
Oh.
And so, yeah, and Art actually pointed that out because, when you looked at the amp draws from these fans, this one's about 0.14 and this one's something smaller in the order of the, tenths or hundreds of an amp. So, yeah. Any other questions?
So you got one output for each fan?
What I've one output and LED paired up, it jumped into one output, physical output in the PLC. Initially, I was gonna do an individual output for the light, the fan, but I didn't know how to write the PLC. I'm gonna be honest, I didn't know how to write the PLC to do that. One input to control 2 outputs, right? So I just made it so that one output would be a fan and light. So, but maybe that'll be a project for next semester.
Anybody else? Anybody else? Well, thank you very
Very
much.
cut and dry. Thanks, guys.
Thank you.
Yes.